For the Redbird, we had an angle of 35 degrees, its mass is 1 kilogram, and the force is 200. To find the velocity, we did the kinetic energy equation, which is 1/2 mass times velocity squared. We plugged in the force of 200 and 1 for the mass, and half of 200 is going to be 400 squared with the velocity squared, which is going to be 20 equals our velocity. To find our range, we plugged in velocity squared times the sine of 70. To get 70, we did 2 times 35 degrees divided by 9.81, which is our gravity. So 400 times the sine of 70 divided by 9.81 equals 356.4 over 9.81 to get a range of 38. Then to get our maximum height, we did 400 times 0.6579. To get that, we did the equation of velocity squared times the sine squared theta, also known as 1 minus the cosine of 2 times theta divided by 2. And then we got 400 times 0.65797 divided by 2 times 0.81 to get a maximum height of 6.73. And to put into vertex form, we did y equals a times x minus 19 squared plus 6.73. To plug in for our x value, we did 38, which is our range, minus our vertex, which is 19 squared plus 6.73. To get, when you get 38 minus 19, you get 19 squared, which is 361 times a, since you minus 6.73 from both sides. And then you divide 361 divided on by negative 6.73 to get a negative 0.0186 as your a value. Then the equation you're going to plug in for your Desmos is y equals negative 0.0186 times x minus 19 squared plus 6.73.
Okay, so for the Blackbird, we had a starting height of 5 meters like the other birds. Our gravity was 9.81, the mass of the bird was 2 kilograms, and I chose the launch angle of 45 degrees. So to find the velocity, we first had to use the kinetic energy equation, which was, when I plugged everything in, it was 200 is equal to 1/2 times 2 times the velocity squared. 200 is the kinetic energy that we used for the bird, and 2 is the mass of the bird. So upon solving that, 1/2 times 2 is 1, so that was 1 times velocity squared is equal to 200. So to find that, I had to then divide 1 by both sides, which is obviously still 200 is equal to velocity squared. So then to find velocity squared, I had to square root both sides, which the square root of 200 is 14.14. So my velocity then was 14.14. So then to find my range, I had to use the range equation. Upon plugging everything in, I got 200 times the sine of 2 times 45 is over 9.81. 200 being the amount of, 200 being velocity squared, the 45 being the launch angle times 2, because that's what the equation calls for. When solving all that, it was 20.39, which is now our range. Our max height, now I have to use the max height equation, which is h is equal to velocity squared times sine squared times theta is over 2 times gravity. So when plugging everything in, I got 200 times sine squared times 45 over 2 times 9.81. To solve for sine squared times 45, I had to do 1 minus cosine 2 theta over 2, which would be 1 minus cosine 2 times 45 over 2. That equaled 1/2, so then I plugged that back in for sine squared times 45, and I got 200 times 1/2 over 19.62 is equal to the max height of 5.09. So now our max height is 5.09, my range is 20.39, and my velocity is 14.14. So now I have to use all those to plug it into vertex form. So my equation down here, y is equal to a times, in parentheses, x minus h squared plus k. So I had to plug in my range for x minus half my range for the h value, because that would be the line of symmetry, plus k, which k is my max height. So I got a in parentheses 20.39 minus 10.195 squared plus 5.09. So when I subtracted 20.39 minus 10.195, it got me 10.195 squared plus 5.09, which equaled 103.94 a plus 5.09. So I subtract 5.09 from both sides because now the y is equal to 0. It got me negative 5.09 is equal to a times 103.94. So when I divide 103.94 from both sides, I got my a value of negative 0.0489. So then my final vertex form equation is y is equal to negative 0.0489 times x minus 10.195 squared plus 10.09.
Okay, so I did the yellow bird, and to start out, I used the energy equation to find velocity. EK equals 200, which is in kilojoules, and that is our starting energy as given at the beginning of the project. I used 1/2 because that was a given number, and 1/2 is my mass. So now we just have to find the velocity. So I took 1/2 and created 0.25 because 1/2 of 1/2 is 0.25, and then 0.25 divided by 0.25 takes it out, and 200 divided by 0.25 creates the 800 you see here. Then I have to take the square root to find the original v. So I take the square root of both numbers and come out with 28.28 as my velocity, and that's in meters a second. Moving on, I have to find my range. So that uses this equation right here. I plugged in my velocity squared for 800 because over here 800 is my velocity squared. And then I had to multiply it by sine times 2 times theta, and theta is my launch angle. So my launch angle is 60 degrees. So 800 times sine 2 times 60 over my gravity, which is 9.81, and I come out with 70.6 on my calculator. Moving to the maximum height equation, I'm using all of my past knowledge on this height equation. So velocity squared times sine squared times 60 over 2 gravity. So velocity squared, as I said earlier, is 800, and then to find sine squared times 60, you have to use this equation, or this formula over here. 1 minus cos 2 times 60 over 2. So cos 2 times 60 is going to be negative 0.5. And then 1 minus negative 0.5 over 2 is going to leave me 0.75. That's what comes out. So I plug in, since that my launch angle is in here, I take all of that out and replace it with 0.75, which is my answer, and come out with 30.581 through that formula. Now I have to put all this in a graphing formula. I have to put it all in vertex form because we already know our maximum height. So we have problems here though, because we don't know the A value, and we need the A value in order to write it in vertex form correctly. Which means we do have to find that A value. So we already know our H and our K. Our H over here is going to be 30.581 due to maximum height. And then for the K value, we just take our range and split it in half to find the midpoint line. So X is going to be our it's going to be our 70.6, which was way back there in the range. And we have to put all of our variables other than the A have to be filled. And then we come out with, right here, it was 1,246.009, and then over here we subtract the 30.5 and 1. 30.5 and 1 is over here. And after dividing by 1,246.09, come out with 0.0245. Then we just plug that into our A and take out the range from the X, and we have our vertex form.
Okay, so for the second little blue bird, the launch angle was 30 degrees. The mass was still 1/4 kilograms like the other little blue birds, and we used the kilojoules of 100. And so first, to find the velocity, it's the exact same as the first little blue bird, so I just used the same work from the little blue bird from number 1 and got the same answer as 28.28. But the range would be different, obviously. So I plugged in 800 times sine 2 times 30 over 9.81. After plugging all that in, because 800 is velocity squared and 30 is our launch angle and 9.81 is our gravity, after solving for that, my range was 70.62, which coincidentally was the same as bird A. So now I have to find the max height using the max height equation. I had to plug in velocity squared, which was 800, and I had to plug in my launch angle, which was 30, and the gravity, which was 9.81. So 800 times sin squared times 30 over 2 times 9.81. So to find sine squared 30, I have to do 1 minus cosine 2 times 30 over 2. So when I do that, I got 0.25. So 800 times 0.25 over 19.61, which is 2 times 9.81. That final answer was 10.19. So since I have all these now, I have to plug them into the equation. So when I plug these in, it's y is equal to a times 70.62 minus 35.31 squared, because 35.31 is 70.62 divided by 2, plus 10.19. So what I do here, 35.31 squared equals 1,246.7961, and I have to subtract 10.19 from both sides. So negative 10.19 is equal to a times 1,246.7961. Now I have to divide this number from both sides, and when I do that, my a value is equal to negative 0.00817. So now my new equation is y is equal to negative 0.00817 times x minus 35.31 squared plus 10.19.
For the little blue bird, that was 60 degrees for the launch angle, 1/4 for the mass. To get the velocity, we did the connect equation, which is 1/2 times the mass times velocity squared, 1/4 being the mass. 1/4 times 1/2 is 1/8 times velocity squared. You do 1/8 on both sides, and you get 800 for the force. 800 for the square root, you're going to get velocity as 28.28 for velocity. Then you need to plug that in for the max height, with having 800 as your velocity times the sine squared times 2 times theta, also known as the 1 minus the cosine of 2 times theta divided by 2. And with that, you get 0.75 as the sine squared 2 times theta divided by 2.981, which is 19.62, and you get 30.581. For the range, we had to do 800 times the sine of 2 times 60, 60 being our launch angle, divided by 9.81, which is our gravity, and we got 70.62. Then we had to do the vertex form, which is y equals a times 70.62 minus 35.31 squared plus 30.581. Then we did 70.62 minus 35.31, which is 35.31 squared, to get 12,046.7961, and you do minus 30.51 on both sides, and you get negative 8. You get a equals negative 0.0245.
Okay, so for the bluebird, the launch angle was 40 degrees, the kinetic energy was 200 kilojoules, then the mass was half a kilogram. So to find the velocity, I had to use the kinetic energy equation. So when I plugged in the kinetic energy, which is 200, and I plugged in the mass of the bird, which is a half, it was 200 is equal to 1/2 times 1/2 times velocity squared. So solving that, 200 is equal to 1/4 times velocity squared is what I got. So then I had to divide 1/4 from both sides to get it away from v squared, which got me 800 is equal to velocity squared. So then I had to square root that from both sides, and the square root of 800 was rounded, 28.28. So now my velocity is 28.28. Moving on to the range, I had to use the range equation, obviously, which was velocity squared times sine of 2 times theta over gravity. So plugging that in, it was 800 is velocity squared times the sine of 2 times the launch angle, which is 40, over 9.81. Which, when you do that, it's the sine of 80 times 800 over 9.81. When you solve that, your range is equal to 80.31. Moving on to max height, I had to use the max height equation. So I had to plug in for velocity squared times sine squared times 40, which is the launch angle, over 2 times gravity, which is 9.81. The velocity squared was 800. But to find sine squared 40, I had to use 1 minus cosine 2 times 40 over 2, which got me 0.4132. So 800 times 0.4132 over 19.62. I got my max height of 16.848. So using all that information, I had to put it all into vertex form. So I plugged in my range minus half of my range, so y is equal to a times 80.31 minus 40.155 squared plus 16.848, which is the max height. So what I had to do then is I had to do 40.155 squared, which is 1,612.424, and I had to subtract 16.848 from both sides. So then my new equation is negative 16.848 equals a times 1,612.424. So then I have to divide 1,612.424 from both sides, which got me my a value of negative 0.01045. So my new equation is y is equal to negative 0.01045 times x minus 40.155 squared plus 16.848 plus the 5, so it would really be plus 21.848.
Okay, so I'd just like to specify again that the velocity is going to be the same for this as the other two little birds because they're the same speed. So what we do have to find is going to be range, max height, and our formula for each bird. The range is going to be 40.77 due to the work done here where the launch angle is 15. You plug in what you found earlier with the 800, and you just plug in 15 because it's a separate launch angle. You get 40.77. And then almost same thing with max height. You plug in 15 as your launch angle, solve for sine squared, get 0.067, and you solve using that, and you come out with 2.733 as the max height. Then you just go down to your vertex formula, and you solve for your a as done before. So you're taking out 2.733, and you get 415.548 over here inside the parentheses. After you square it, it's 450.548. And then you divide by 415.548 on both sides, and you get 0.00657 as your a value. And you just plug your a back in to the a spot, and then put x and your k and your h over here.